67. An environmental engineering group has collected core samples from the Earth to determine if they are contaminated. The samples were weighed in kilograms as follows. So these are just the weights of the samples. And you can see these numbers here. I did enter these in the calculator already, so we're ready to go with that. Um, we're going to I'm guessing I want to create a box plot, a combination box plot and a histogram. It says determine if the mean and standard deviation is an appropriate way to summarize this data. And if so, compute both the mean and standard deviation using your calculator. If not, use the median and the interquartile range. Consider the precision of the measurements of weights when deciding how many decimal places to use in your answer. I would say because these are given to the nearest whole kilograms, that I'm going to just give my answers to whole kilograms. I'm not going to claim any decimal values. This whole thing about determine if the mean and standard deviation is an appropriate way to summarize this data. There's two things that we really should be thinking about. If our distribution is symmetrical, that means it's not skewed to the left or skewed to the right, but it's got symmetry within it. And there's not the presence of outliers. And right now, I would say use your calculator in the modified box plot. If it's not flagging anything as an outlier and it looks fairly symmetrical, you don't think it's skewed one direction or another, then use the standard deviation and the mean to summarize the data. If there are outliers, we've seen the effect outliers can have on the mean, and the median and the IQR, the interquartile range, kind of resist being manipulated. So if there are outliers or it doesn't appear to be symmetrical, then we would use the median or the IQR. So let's go ahead and look at the steps for plotting this data on our calculator. So I did already hit stats edit, and you can see I've got the values here. Now that the values are here, I'm just checking out the stats plot. So plot 1 I've got set up as a modified box plot. It's turned on. Our data I did store in list 2, so I'm changing that. I stored the data in list 1 rather, so I just changed list 1 to list 1 instead of list 2. So this is all set up. So I'm now just go up here and I can flip over to plot 2. So just hit the over arrow. Really, it won't do that. There it goes. And I'll press enter there. So now I'm looking at my second plot. It is turned on and it is a histogram. Now the number of data points, let's see, that's a thing, right? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 26. Square root of 26 is 5, so I probably should have a about 5 bins. It appears that it looks like the smallest number I see is 10 and the largest is 70, almost 70. Let's just see what our calculator does, and then we might modify it to change the number of bins up. So to see this now, I'm just going to hit zoom and 9, and this will let the calculator. Whoops! Didn't like something there. Second stat plot. Nope. Second stat plot. Oh, I know what it didn't like. It didn't like that on plot number 2. I left it on list 2 for the data. So it's basically complaining like, look, there is nothing in list 2. You can't ask me to do a stat plot on it with no data. So I'm changing that to list Y. How's that going to make sense? Let's see. Second list 2. There we go. Or list 1. Okay, so now both of these are reading the data from list 1. So now let's hit stats or zoom. I did that again. Oh my goodness. Second list 1. Enter. Now I'm going to hit zoom. I can't hit zoom from there. Let me quit this. I'll hit zoom and 9, which is zoom stats. There it is. Unfortunately, I've got 1, 2, 3, 4, 5, 6. There's 7 bins. I don't want to have 7 bins, so I'm going to make my bins wider. So I'm going to go into the window. Right now the width of the bins is 10 units, and you see I'm going from 10 to 78. Let me make it go from 10 to 80. 10, 20, 30, 40, 50, 60, 70. That's two. Let me make the bins 15 wide. I might come back and change that. Oh, and also let me give me a little bit more room at the top for the Y's. So I'll make this 12 so that they don't bump into each other. Let's look at this. That's only 4 bins. I think I want another bin. Let me go back here. So that was with it 15 wide. Let me maybe make it 12 wide. So it's going to go from the first, it'll start at 10 and then go to 22 and then add another 12, etc. And let's make the Y max a little bit bigger. I'm going to make it 15 this time and hit zoom or hit graph again. Whoops. I've got 5 bins. And look at this, is very symmetric looking, right? There's 5 bins, perfect symmetry, left and right, looks great. So because of that, I'm not going to use the median and the interquartile range, which is unfortunate because it's very easy to calculate that from the graph. Let me remind you that if I hit trace right now on plot 1, the median is just this number right there. So the median of this data set is 4. And the interquartile range is the difference between this number, which is 31, and this number, which is 50. So 50 minus 31 would be the IQR. Well, because this is symmetrical and because no outliers were flagged on my modified box plot, I'm going to use the mean and the standard deviation. So let's go ahead and do that. So we are going to go with calculating the standard deviation and calculating the mean. Well, the mean's pretty straightforward, right? We could just get that hitting stats and one variable statistics. And we talked about calculating standard deviation in class on Friday. So let's kind of review the calculations for that. And it involves some list operations. So if I want to find the standard deviation, right, what I'm doing is I'm figuring out how much each one of these values deviate kind of from the mean. And what we had said was let's take and first we found the, what did we find? We found the mean absolute deviation. But then to find the standard deviation, what we needed to do was we need to take and actually the median in this set was 40. I already looked at that calculation, but I'm going to hit second list 1. So that's all. That's going to be all the values in list number 1. In fact, if you look at it, I'll just hit enter, and it's like, oh yeah, those are the numbers in list 1. But what I want to do is I want to take those numbers in list 1, and I want to subtract from every one of them the number 40. Okay, and then I'm going to go ahead and square all of those differences. So what that is that's the square of the differences. It's the square of the differences between each value and its mean. And when I press enter, you can see I get another list right here. It's a beautiful list. Oh, look at that. That's cute. When it was 40, 40 minus 40 is 0, right? But there they all are. And notice they're all positive numbers because we're squaring them. So what I need to do next is I need to figure out the mean of that list of numbers. And then once I have the mean of that list, I need to take the square root of that number. So to get the mean of this list, I'm going to store this in list 3. So there's a button here that says store, so I'm hitting at store. Whoops. And I'm going to store that list, right? That answer means store this previous line. So I'm going to store this, and second, I will put it in list 3. So enter. So right now, this list is in list 3. If I go back to my stats editor, you can see I've got list 1, and over there I've got list 3, which is what? Those numbers are all of the differences between a number in this list and 40 squared. It's the squared. It's the square of the difference between each number and the mean of this data set. So I need to find the mean of this. I need to find the mean of list 3. To find the mean of this list, it's stats calc, and I'm going to do one variable stats on list 3. There we go. And I get that the mean of that data set is 246.1538, etc. Right? Now, the answer that I'm looking for, the standard deviation for this data set, is the square root of that number. So I'm going to forget that number if I don't write it down. So let me write down 246 point, I'll just do 154. 154. So I'm going to take the square root of 246.154. And when I do that, I get 15.689. So my standard deviation is, I should probably round that to 16, right? The standard deviation is 16, and the mean I said was 40. So yeah, I think I'm going to leave it there right now. I'm not going to point out something. You'll probably be angry with me later when I point it out later, but I think I'm going to leave it right there for now. So let's, more to come. The story is not over. So let's go ahead and write down our summary. I would say no outliers and a symmetrical data set indicate we good to go. No, we may use mean and standard deviation. To describe our data set. So our mean, the typical value that we're looking at, is 40, and then how much do individual elements deviate from that mean? Well, the standard deviation is about 16 kilograms. So, you know, if you look at it, these values, they're varying by, well, no, that's not incorrect. I wouldn't want to say that, but the standard deviation is 16. And if you were within 2 standard deviations of that mean, pretty much all of your data is going to be living in that spot. So let's go ahead and wrap this up. We'll say that's the end of this question.